This is Akashvani. In today's edition of Science Talk, you will now listen to a talk entitled Advanced Materials Challenges and Standardization Need for Net Zero Technologies. The talker is Professor Fernando Castro, Chair VAMAS, Versailles Project on Advanced Materials and Standards, NPL UK.
We all know that the challenges of climate change are really a problem for everyone in the world. It's probably the biggest challenge we have facing humanity. And it really needs advanced materials to support the development of new net zero technologies that would address those challenges. When we think about addressing those challenges, we have to think that there are a big challenge in accelerating innovation. What you can think about is that we need technologies to be out there today. We don't need them to be out there in 10 years. So what's the challenge? One of the biggest burdens when you try to innovate is that of confidence. In all stages of the innovation cycle, people need confidence. Industry will need to trust that the data provided by university, where they say that this new material is fantastic as a new solar cell or as a new battery, will also work when they develop in industry. When they try to develop the supply chain, they need to trust that two suppliers will give them data that they can compare, so that they know that one material is better than the other, so that they can choose the best material for manufacturing. Governments need to be sure that these materials will be safe and that they can put a regulatory framework in place. And measurement is really key to provide that confidence. We call it in our area materials metrology, which is the application of measurements to materials and technologies based on materials. And they're really important to accelerate innovation by improving reproducibility, reliability, comparability of measurements, but also to enable discovery, enable scaling up, which then reduces investment risks and facilitate the uptake of advanced materials by industry. When we talk about materials metrology, different parts of the innovation chain will think about it in different ways. Universities might be playing a significant role in developing new methods that they use to understand materials properties, understand how to improve devices. But then there is a second stage that we call pre-normative research, is where a lot of the national measurement institutes around the world will take the leadership in developing the science that will make these measurements robust and reproducible. And this is really critical so that the industry can make use of them in a reproducible way. Finally, standardization organizations need to write standards that governments can use to legislate and industry can use to apply throughout their supply chains. The biggest challenge we have when we try to accelerate innovation is the fact that for established materials, there are standards out there. But if you want to bring new materials into the market, there are no standards. So the role of metrology becomes extremely important in accelerating that process, providing this best practice early on so that companies can innovate quickly with confidence. That's not a problem that started now. Already in 1982, during a G7 meeting of the Global Agreement on Tariffs and Trades, the heads of state of the G7 countries, together with the European Commission, were discussing how to establish collaborative programs of work across the globe. Out of 18 projects proposed, one of them was dealing with advanced materials through pre-standards research that led to the formation of VAMAS. And throughout the first 2 years, this group was actually reporting directly to this working group of the G7. And there was a significant news at the time in both public press and scientific press about these activities. Since then, VAMAS has been growing steadily and continues to attract a huge amount of activity. So we started with the 7 countries plus the European Commission, and since 2017, we doubled the number of members of the steering committee to 16 members across the whole globe. We also established collaborations with a number of different international organizations, including ISO, IC, and others, to help us disseminate the output of the work that VAMAS establishes and have been working over these past 40 years. So what is it that VAMAS do? Essentially, I can summarize that in 3 words. We provide foresighting. We organize meetings such as these ones, where we bring experts together to discuss what are the biggest challenges facing advanced materials in specific areas. We use that then to inform how we can establish new global collaborations. So these are technical, scientific projects that we put together, bringing scientists across the globe to deliver the science that's needed to establish best practice. And we then disseminate very strongly across industry, across standardization committees, and so on. That leads to a number of different outputs. That can be standards, but also can be new products and services that industries deliver in their own countries. To give an idea of scale, last year alone we had more than 40 projects with more than 300 participants across 40 different countries. That's just to give you an idea of the scale of the activity. And why these people want to participate? Typically because they can get new insights into what these new materials can be used for. They can be more confident in how to apply them in their own industries, but they can also influence best practice around the world. Especially scientists in universities might be developing really good scientific outputs that could be applied worldwide, and it's an opportunity for them to do that. But most importantly, people work within VAMAS to increase impact and amplify impact. We have a formal structure where we have a VAMAS secretariat that is composed of chair, which is currently myself, and the secretary, that's Sam Gnaya, sitting here in the audience today. We have a steering committee with members of all the member regions that then appoints the technical working areas that will deliver the technical work. These will have their own chairs, which are scientific experts in their fields that can appoint project leaders. These project leaders can come from anywhere in the world, and they can attract participants from anywhere in the world. So essentially anyone can participate. You don't need to be part of VAMAS. You don't need to be a country member of VAMAS. And the reason for that is that we can then attract the very best talent from anywhere in the world. There's no fee associated with that, so there's no payment exchange either way. But VAMAS also don't provide funding, which means that all participants are there because they really believe that that's the right thing to do and they can benefit from the outcomes of that work. So everyone involved tends to be very proactive and very invested in having the best outcomes. And if you want to know more, there is a VAMAS website where you can find the current topics and current areas where projects have been run. If you look at the website and find these are not the areas that you think are the most important ones and you think they're new areas, you can also propose new activities yourself. And we have a formal procedure to do that. But typically there are a few things you have to keep in mind. Is one, it has to be related to advanced materials. It has to involve global collaboration, and it has to be something that will have a real impact in the world. Just to give an impression of the current technical working areas, these are listed here together with the flags of the countries that are currently leading those activities. When a technical area finishes their work, we'll close those areas, and when new activities are required, we will open new activities. So in a nutshell, VAMAS provides an open innovation and standardization network where you can discuss openly without having worries about IP, about anything that will stop you from interacting, with a common view of establishing best practice and standards globally. The work that VAMAS has done over the past 40 years has led to hundreds of international standards being published, to new products and services being launched, and to dissemination of best practice to thousands of different organizations across the globe, and help us understand what are the pressures that we need to address in order to tackle climate change, and in particular how to develop these new technologies that are required to achieve net zero in the coming next years. Thank you very much for your attention.
You just heard a talk entitled Advanced Materials Challenges and Standardization Need for Net Zero Technologies by Professor Fernando Castro, Chair VAMAS, NPL UK.